page 78. 78. 78. Okay, wait a minute. You can't see the color of it. I'll change to a different color so that you can see it now. 78. So you should know that this entire sheet is what you have already been doing, but instead of me just giving you the triangle and saying solve for x, I'm embedding it within a word problem, and then you solve for x. I know word problems are everyone's like least favorite. I get it, because you don't like reading in some cases about stuff you don't like, and then you also don't like feeling intimidated when you read it and not knowing where to start. So hopefully I can give you some tips on how to approach it and get it right every time. The first thing you need to keep in mind is with word problems, reading it one time or skimming it is not enough. You need to read it 2 times. You read it once just to kind of say, okay, I read it. But then you need to read it again and try to visualize what you're reading or draw a picture. Most of the pictures have been given for you. Given to you. You're welcome. But if the picture is not given to you, what is the shape? What's the shape that we've been dealing with? A right triangle. So if the picture is not given, draw a right triangle and then fill it in. There are 2 new vocab words on here, though. 2 new vocab words. They're at the top. If you have a highlighter, that'd be great. If you don't have one, no big deal. You could box it in. You have angle of elevation and angle of depression. Angle of elevation, angle of depression. Let me explain to you what these are so that when you are given... Liam, did you pass the paper over? Was there another one? When you are given the angle of depression, you need to know where it is in the picture so that you can label it correctly. Or vice versa. If you're given the angle of elevation, you need to know where to label it. All right. So the good news is these 2 new vocab words are self-explanatory. What does elevate imply?
Down.
Going.
Elevator.
Right. I didn't say elevator.
Elevators go down.
Right. Elevate.
You
ever hurt your leg, your ankle, or your foot, and been told to rice it, rest, ice, compression?
Yeah, compress.
Is it compress and then elevate? You with me? Or have I lost you? You're supposed to rice it. But anyways, what does elevate mean? You don't go home and then just drop it down below your waist. It means you're going to
go up, son.
Pick your foot up and prop it up higher than your waist so that the swelling will go down. Okay, so angle of elevation is exactly what it implies. It's the angle formed by looking out at the ground. We're implying that we're looking at the ground. Imagine straight, don't think that way. Like looking straight at the ground and then elevating your head to look up at something. So let's draw a picture. It would be the angle formed, let me draw it better, by looking at the ground and raising your head upward. You're going to think, I want you to write this, think elevate means up. Now, yes, I realize elevator goes up and down, which is why you don't need to think of an elevator, because that's going to draw confusion. You need to think of the word elevate. If you have a swollen ankle and you need to elevate it, you would sit down, raise your leg, and prop it up, okay? Angle of depression is the one that confuses people the most because the angle is actually on the outside of your picture. I'm going to show you what I'm talking about when we come to one. But there's a connection between the two that makes it easier. So angle of depression always implies that you are up high on something. You're either up on the top of a cliff, you're on the top of a mountain, you're on the top of a building, you're up in a tree, a bird is in a tree. It always starts with something is already up off the ground. Angle of elevation is from the ground. Angle of depression implies something's already up high and it's tilting down. So you have what's called your line of sight because you're up high, and then it's the angle of depression would be the angle formed when you lower your head to look down at something. Okay? Now, how do you remember this? Well, you should know what elevate means, and then depression would be the opposite. But another way to think of it is, and this is not trying to like imply a stereotypical connotation here. I'm just saying, like, if someone was to draw a cartoon figure that is happy-go-lucky and then they become depressed, how do they convey that in just a cartoon figure? What do they usually do with the cartoon figure's head? Like to show that they're, yeah, right there, you just did it. It just, your head drops, you know, like usually those cartoon, especially commercials, the animated commercials for depression medicine, they always have like a little cloud of rain following the person that's depressed and they're always looking down. So the way to remember tie-in here, I'm going somewhere, is person happy-go-lucky, and then let's say something really bad happens and now all of a sudden they have depression. Let's go with moms that have babies and have postpartum depression. It's real. You're happy-go-lucky, and then now all of a sudden your hormones are out of control and you have no clue what's going on, and you're responsible for this little human and you don't even know what to do with it. And that you're depressed, right? So this, I want you to think of becoming depressed and your head tilts down. Okay? So think tilting head down. And that's what I'm implying. Okay? Now, hopefully you wrote that. Hopefully you're not sitting there with sunglasses on, cherry picking what you're going to write.
No,
That's like a shield. Like a shield. This.
Should you get off the couch?
No.
Oh, well then you need to participate 110%.
So
I'm sorry, all I heard was, yes ma'am. That's all I heard. All right, you got angle of elevation, you got angle of depression. The beautiful thing here is they have some type of connection. They're two totally different things when you label the picture, but they have a very consistent connection. Let me see if you can figure it out. If you have your angle of elevation, which always refers to the ground, then you have your line of sight, which is always referring to something up high and you're looking out. And then you have some angle of depression, and then you have an angle of elevation that's like right here. What can you tell me? What looks familiar here? There it is. This is the tie-in. Every angle of elevation and every angle of depression within the same problem are actually congruent because of alternate interior angles. Now, I would not draw that there. I would draw that maybe right here on the right or up at the top. But the takeaway here is that the angle of elevation and the angle of depression are always congruent because of alternate interior angles. Okay? So if I give you, let me take that away. If If I give you the angle of depression, I have also just secretly given you the angle of elevation, and I will show you why that is helpful when we get to one of those problems. Since the horizontal lines are parallel, the angle of elevation will be congruent to the angle of depression because the angles are considered alternate interior angles. Alright, now let's dive into the word problems. Number 1, car is driving down a hill that's 500 feet long at an angle of elevation of 32 degrees to the nearest foot. I need you to underline this and make a note. When they say go to the nearest foot, mile, centimeter, kilometer, inch, angle, whatever, they're talking about whole number, okay? They're saying go to the nearest whole number. That's their sneaky way of saying how to round. Alright, let me read the question. To the nearest foot, what is the vertical distance covered by the car? You staying with me, everybody? Well, you have a picture drawn here, so you don't have to worry about drawing your own. You've got your 32-degree angle of elevation here. You have the incline that measures 500 feet long, the hill. And they want what's the vertical distance. Vertical implies straight up and down, so that's where your variable is.
They just do true.
Yes. Yes. That's it. It's just embedded within a word problem. So let's go. What trig function are we going to use here, y'all? This is a sine problem. Do y'all see it?
I see it.
With a missing side, correct?
Uh-huh.
So sine angle equals fraction bar opposite over hypotenuse. Now, are we using inverse or are we elbow arrow?
Elbow.
There it is. And it's a short and sweet one, right?
Yeah.
Go to the nearest whole number. Confirm. Did you get? There you go.
Word problem will call.
Oh boy. Such a joy. Wow, what a joy.
Are you in degree?
Oh, boy.
Did you type 500 sine 32?
Who's on the work?
Shoot, oh, it's 600. I thought you said 65.
Oh.
That's different.
Okay. Number 2. Do y'all know what a billboard is?
No.
Yeah.
And I'm not judging if you don't.
It's the thing you say when you're going.
When you're driving mainly down the interstate, right?
Yeah.
When you're driving down the interstate, it's the free, it's not free, but it's the way that businesses advertise to commuters that they want you to get off on this exit because their business is there. That's a billboard. You are standing 35 feet from a billboard. The angle of elevation from where you're standing to the top of the billboard is 58 degrees. How tall is the billboard? I have no picture given here, but Ms. Holcombe said, what is the shape we've been dealing with? A right triangle. So draw a right triangle and then kind of label the sides or the info based on what they gave you. You try it first. I'm going to give you 30 seconds. Then I'm going to draw the answer or the picture on the board.
They start with you.
I really don't know. Imagine standing in a big field looking at a billboard. Then filling in the info based on what they tell you, the numbers.
They're only giving you one more piece. Oh, I did 59.
It's the
So I
angle,
got
right?
56, guys.
It is 56. All right. So I'm going to draw like a little fake billboard right here. Right? You got a billboard. Now you're standing how far away from it?
35 feet.
Okay, so where would 35 go?
On the bottom, across the leg.
Yeah, shortest distance between two things is that straight line. Don't you dare throw 35 as the diagonal. You are 35 feet. It's kind of hard to read my numbers now.
I forgot to draw that person. That's the problem.
You're 35 feet from it. Where does 58 go?
It's the.
Well, there's only
it's
two
the,
angles.
It's,
It's either with the ground or it's at the
your
top on the
elevation.
outside.
it's your elevation.
It's the elevation. Elevation always starts from the ground. So it's right here.
Oh, boy.
And then it says, how tall is the billboard? Which means my X goes where?
On the
On
side.
the side. How tall implies strictly vertical, not diagonal.
Means we're doing tangent here, guys.
Very good. Hypotenuse is blank. It's a tangent problem with a missing side. So tan angle equals fraction bar. Opposite is x. Adjacent is 35. I accidentally wrote a thumb. 35. And again, this is another short and sweet.
Oh, boy.
And I went to the nearest foot because it says to. So the nearest whole number. Did you get it? All right, number 3 is part of your homework. Let's go down to number 4. Satellite is launched at an angle of elevation of 72 degrees. Suppose the satellite covers a distance, which is d, of 8 miles during launch. What's the vertical height? What did they just give me right here? Oh, when did I type that?
Yesterday.
Should have typed that.
Yeah, mark that one out.
Yeah. No. I'm saying I should have typed.
Yeah.
Oh, nice.
That question's useless.
Yeah. Dang it.
I'm construction worker. What, you're a construction worker? My brother.
All right. Go back to this.
No, you didn't. I know you were going to it. You didn't. I did.
Okay, it says suppose the satellite covers a total distance d of 8 miles. What is this telling me right here?
D equals 8.
They're saying to let d equal 8.
That's right, I saw that.
I'm surprised with your sunglasses on.
Yeah.
You have this picture right here, right? You have this picture right here. So now we know that d is 8. I'm just going to redraw the picture. We have 72. I wish I'd stop talking. We know d is 8, and it says to find what? H. The height. It says to go to the nearest tenth, by the way.
I just tried to draw a triangle and I just trapezoid. I'm so proud of you.
It is a sign problem. So trig function, angle measure equals fraction bar, opposite over hypotenuse, another nice and short problem. And to the nearest tenth, what'd you get? And we're talking about miles. You need to learn to write your unit of measurement. Caleb, you with me?
Your name's not Caleb. Yeah, I don't think Evan knows. He identifies as Caleb. I think it's
Hey,
tell him you identify
D
as
is
Caleb.
part of your homework. They are saying that now it has a vertical height of 3, so what distance would be covered? So it's fill in the info that they give you. They're reversing it. So I would redraw the triangle like we did there, but with the info they give you.
I'll go home and do it.
Come down to 5. 5 is short and sweet. There's no picture drawn, but you should be able to imagine if a ladder's leaning against a house. Don't pack up. It's Wednesday, remember?
Oh, yeah.
If a ladder's leaning against a house, then you should know what it looks like. So draw a right triangle. Label which side would be the ladder. Now they are saying that the ladder measures how much? So the 20 needs to go on the side that would represent the ladder. A lot of people get this one wrong because they accidentally put the 20 with like the vertical. They think this is the ladder, straight up and down, and if you were leaning a ladder against a house, it would definitely be a diagonal,
Not necessarily.
right? So anyways, it says, what angle does the ladder make with the ground? This time you're finding a missing what? Angle, which means theta goes in the triangle. It's making it with the ground, so you put it at the bottom. And it's inverse trig. Y'all staying with me?
Yes, ma'am. Sorry, I put it up, but I got it back down. So you can't yell at me yet.
I went to the nearest tent, and then I wrote, or the nearest one. So I want you to do 5. It is inverse trig. Go to the back. Do cosine? Inverse? Are you in degree?
Yeah.
Did you do 420? Okay, look at this one. Number 6, I want you to do it by yourself for homework. It is exactly like the billboard problem, but this time you're finding the missing what?
Angle.
It says, what is the angle of elevation, which means what's the angle that's with the bottom of the triangle? So it's an inverse trig problem. But it's going to be like the billboard in terms of drawing it, labeling it. A skyscraper, if you've ever been to Nashville, Knoxville, or Atlanta, a skyscraper is just a exceptionally tall building. Okay? So just, if that bothers you, think of it as another billboard problem. A billboard. They are giving you the height of the skyscraper here. What are they saying it is? And height implies what direction? Vertical, up and down, right? They're saying you're standing 350 feet away from it. Where would that go?
Oh, me.
Once again, remember, it's always the shortest distance. We're talking strictly from bottom to bottom. All right, let's look at 7. You go to a music concert with some friends. You sit halfway up in the bleachers. The angle of depression from your horizontal line of sight, meaning you're sitting like right here, right? All right, and you're looking out. You with me? Looking out, straight out. Then you tilt your head down to look at the stage. They're saying that the angle of depression from where you're sitting in the stands is 24 degrees. What did we say on the front of the paper about the depression and the elevation? Alternate interior. So when I give you, this is what I was talking about. The angle of depression trips people up because they tend, let me show you with red, they tend to put it here, where it's in the top of the triangle, which would imply I'm already looking down, and then I look straight down at my feet. That's wrong, okay? Angle of depression is always on the outside of the triangle with that line of sight to the diagonal. And then once you know it, you can come inside the picture and put the angle of elevation as the exact same number because they're congruent, okay? So there's actually 2 ways to solve this, and it depends on if you're closing in the triangle over here. If you want to, you don't have to. I tend to use the one at the bottom. So depending on which one you use determines which trig function you're going to use, but you'll come to the same answer. You should get 111 here, but this is for you to do for homework. You should get 111. All right, go to number 8. Number 8 is a designer window. the designer is creating a new and unique entryway for an art gallery. We've got all the information labeled in our picture. It says how tall should the entryway be if the inner length is 20 feet. Thank goodness you don't have to draw the picture. It's already there. You should notice that this picture is more than I really need. I only need one side of this, right? If you look at it, it says how tall should the entryway be? What direction does the word tall imply? Vertical. Vertical. So they're saying how tall, meaning find the vertical height of the triangle. And you just focus your attention on one of the triangles here. The 30 degrees is right here. You are going to the nearest foot there, so that's your homework as well. Yeah, and you're going to look for it. All right. Last two. I'm going to help you with the picture. Then I want you to try it. These last two are kind of, they're not bonus, and they're not challenging. It's just they involve 3 steps. Okay? Let me help you out. Look at 9. You are a block away from a skyscraper that's 780 feet tall. Your friend is between the building and you. Okay, picture that. So if I was looking at a building really far away, and then my friend was some distance in between us, me and the building, right? We're both looking at the building. Do you see 2 triangles? Imagine the triangle with your friend and then the triangle with you. Y'all with me? All right, let's draw it. So we've got a building right here. Yes?
Yes.
All right. How tall is the building? 780 feet. I'm going to label it like this. 780 feet tall. And then we have our friend right here. This is our friend. I'm going to put F for friend. Then we have us. Yes? I'm going to put the letter U. Oh, no, I'm not.
That's a problem.
I'm going to put me.
Oh, dude, crazy.
Sorry.
Cussing like a sailor.
Yep. All right, anyways. Okay. I know. The angle of elevation from you to the top of the skyscraper is 42. So where does that go?
Somewhere on
Should be easy. Elevation from you.
The bottom right.
From me, right? Okay, and then the angle of elevation from your friend is 71. So go to your friend. Their angle of elevation is 71. Makes sense. They're closer to the building, so they have to tilt up higher. To the nearest foot. How far are you, not from the building, from your friend?
How far does it go?
Don't worry about a block. Don't worry about that. All right, so look right here. I'm going to highlight the piece that they want. They want the distance from you to your friend. This is a 3-step process. You got to be a problem solver. It's just a puzzle. Can you look at this and tell me, what can I find? 3 steps. 3 things that you have to find that would help me get yellow.
Hey, you take the 42, the sum of the 42.
No.
180 minus 71.
Wait. No, keep going. You're on the right track. The hypotenuse is not necessary.
Find the horizontal for 42, and then you find the horizontal for 71.
That's it. All right. So look at the steps. First, let's find out how far our friend is from the building. Right? So you mute out the rest and you find that horizontal. That would be a tangent. Then imagine this as one big long side for you. find out how far you are from the building, and then subtract the two, and that would leave you with yellow. You do go to the nearest whole numbers on all of them, so you do get nice answers. I'm going to tell you that the answer is 597 feet. I would love to know if you can get there. I'm also going to tell you that right here, which is a very similar problem, the answer is 38.
Snow glasses, snow goggles.
Hey, let me show you this. I know you're packing up. I just want to put it in the video. Two men are on opposite sides of a tower. This one right here is going to involve this type of triangle. Okay? Try it. I'd love to see if you can get it right. I know some of y'all are saying you're not even going to touch this, but.
Oh, God.